Hey guys, all right, so this video is over exponential and logarithmic regression. Um, you have to make sure that you have a calculator for this. So you either need to have a graphing calculator at home that you have on hand, or you can go and download the app that I posted on the website, a link for you to click on that you can actually go download a free calculator. It's a 90-day free trial that will give you a simulator of a calculator that's exactly like what we use at school. And so you should be able to do all of the same stuff if you go and get that calculator. So first, so we're talking about the table to the left shows the year and population in millions of Texas. Using an exponential model, write an equation for the curve of best fit, then estimate the population of Texas in 2020. Okay, so just remember on your tables when you are going to type this in on stat edit on the calculator, you cannot use years. So that first one changes to year 0. 1920 is 20 years from 1900. 1940 is 40 years. 1960 is 60 years, and 1980 is 80 years. Okay, so then you go to stat edit on the calculator, type all that in like we always do, then go to stat over to calc, and we're talking about exponential model. So you want to go down to where it says exp reg, okay, and then enter through, and it will tell you that the equation is going to be f of x equals around 3.10 times 1.02 to the power of x. Okay, and our x here is going to be the 2020, but we're talking, how far is 2020 from 1900? Well, it's 120 years. So our x is going to be 120. So to find out about the estimation of the population of Texas, you plug 120 in for x right there, type that in, and you're going to get around 33.37, which means that that's going to be about around 33.37 million people. Okay, pretty simple, but just make sure that you have to have a graphing calculator to be able to do this. Okay. Number 2, so it says the table on the left shows the closing prices for the NASDAQ stock index at the end of February during certain years. Use an exponential model, write an equation for the curve of best fit, then estimate the year the closing price will reach $10,000. Okay, so 1992 is year 0, 94 is 2 years from that, 96 is 4 years, 98 is 6 years, and 2000 is going to be 8 years from 92. Type that into your stat edit. You should end up getting 518.18 times 1.27 to the power of x. Okay, on this one, it says estimate the year the closing price will reach $10,000. So if we're trying to estimate the year on that, we are trying to find out what our y value is when our x is $10,000. Okay, so no, I'm sorry, I said that backwards. Sorry. We're trying to find out what our year is, our x value, and our closing price is y. So we're trying to find the x value. So we're trying to find what the exponent is whenever our y, our closing price is $10,000. So our y this time is 10,000. So on this one, we're actually going to have to solve some stuff here because we've got to be able to find out what that exponent is. So you just set 10,000 equal to 518.18 times 1.27 to the power of x. Okay, well, the first thing you want to do is we want to get this 1.27 to the power of x. We want to get that by itself. 518.18 is multiplied times this, so to get rid of that, we're going to divide both sides by 518.18. Okay, so 10,000 divided by that is going to be around 19.29 2.83, and that is going to equal 1.27 to the power of x. Okay, so now to find out what the exponent of this is, well, we're gonna have to change this into logarithmic format because we're trying to solve for x. So we know that log base 1.27 of 19.2983 is going to equal x. Okay, so then to find out what that's going to be, we're just going to have to do the change of base formula. So log 19.2983 divided by log 1.27. Okay, whenever we type that in, you should end up getting around 12.38 is our x. Okay, so to figure out what year that is, well, 12.38 12.38 from 1992, well, that's going to be around 2004 is going to be the year. So the answer is 2004. Okay. All right, number 3, the table to the left gives the percent of all workers who are female during selected years from 1970 to 2006. Use a logarithmic model, write an equation for the curve of best fit, then estimate the percent of female workers in 2016. Okay, so we still need to change our years here. Hold on one second. I'm going to open up my calculator. I actually downloaded the calculator on my computer too. That way I can see the same thing that y'all are going to be able to see. Okay, so I actually have the stat edit opened. And we can type these in. They actually did. They started with year 1 right here, and I believe it's because you cannot do, whenever we're talking about logarithmic functions, you can't start from year 0. You can on exponential, but not on logarithmic. I'm almost positive that's the reason why they did that. Yeah. Okay, so what we're gonna do here, instead of starting at year 0, and this is because it's logarithmic, we're gonna start at year 1. Okay, how far is 1980 from 1970? Well, it's 10 years away, but 10 plus that 1 is 11. Okay, how far is 1985 from 1970? Well, it's 15 years away, but 15 plus that 1 is 16. 90 from 70 is 20, so that makes this 21. And 2006 from 1970 is 36, so that makes this 37. Okay, so then you go to stat edit, you type all that in. I'm just gonna type it in to make sure because I didn't type in the other two. 21 and 37. And then we have 30, 35.3, 37.9, 37.2, and 41.5. Okay, and then we are going to go back to stat. We're going to go over to calc. And this time we're talking about logarithmic. So we're going to go down to logarithmic. And logarithmic is actually, it's the one that says ln reg. Okay, because remember that means natural log. So it's going to be ln reg, enter through, and we should get, Yeah, that is all correct. Okay, so we should get, our equation is f of x equals 29.50 plus 2.91 natural log of x is what we should get. Okay, so then it says, then estimate the percent of female workers in 2016. Well, 2016 from 1970, that is going to be, our x value is going to be 47 is what we want to plug in for the x right there. So when we plug 47 in, so we have 29.50 plus 2.91 natural log of 47. And you should end up getting around 40.7 people. Okay. The next one, so it says the table to the left shows the height in feet of a pine tree in the park. When it was originally planted, it was 1 year old and had a height of 4 feet. Using a logarithmic model, write an equation for the curve of best fit, then determine the age of the tree at 20 feet. Well, we don't have years here, so we don't have to change anything. So you can automatically just type that in, and we are actually trying to find the x value on this, so our y is going to be 20. Our equation, when you type that in, you should get 3.82 plus 3.89 natural log of x. Okay, and so then we're plugging this in for the y value, so it's 20 equals 3.82 plus 3.89 natural log of x. Well, you want to subtract 3.82 over, and you should get 16.18 equals 3.89 natural log of x. We're going to divide both sides by 3.89, and you should get 4.16 equals natural log of x. Okay, well, because we have the natural log of x, we've actually got to turn that into exponential format. And so that when you turn that in, that should be e to the power of 4.16 equals x. Okay, and on the calculator, you can do that. You can type in, let me clear this out. Let's see, second mode. Okay, you can type in, so you do second ln and then to the power of 4.16, enter, and you get 64.07. Okay, so around 64 years old is what it is. So 64 years old. Okay, guys, this calculator, it works exactly how what we do on our calculator at school. It has all the same functions, so it's a great download. Okay, all right, flip over to the other side. Okay, so choosing the best model. All right, well, first let's talk about each parent functions. We're going to sketch each parent function. So linear, okay, just a straight line. It's number 4, len reg. Quadratic, to parabola. Okay, quad reg, cubic, something like this. Cubic reg. Quartic, it's similar to quad reg, except sometimes it has that little hump thing in it. Quart reg. Exponential is going to be something kind of like this, and then logarithmic is something kind of like this. Okay, it says to determine the best model, use the correlation coefficient R. The closer R is to -1 or 1, the better the fit. Make sure your diagnostics are turned on to see this value. So what you have to do on your calculator is you actually have to go to your settings and turn on the diagnostics. So let's see, you have to go to, let me clear this out real quick first. Excuse me. I want to make sure you can do it on this calculator online. You should be able to, but it looks a little different. Okay, where's my settings? Okay, so go to mode and then go to stat diagnostics. You go all the way down to stat diagnostics, and right now it's set for off. You want to go to on and hit enter. So you want to make sure that it's black on the on. Okay, so we need to turn that on, that way that we can be able to see our correlation coefficient, which is our R, whenever we type in on stat. Okay, so after you've turned that on, just hit second mode to quit out of that. Okay, so then now we're gonna still be doing the same thing. We're still gonna use stat here. We need to figure out what it's gonna be. Is it gonna be quadratic, quartic, or logarithmic? Okay, so it says the table below shows the operating costs in thousands of dollars of a small business from 2000 to 2005. Which model would fit this data best, quadratic, quartic, or logarithmic? Using the model, write a best fit equation, then estimate the operation costs in 2008. Okay, so because this has a possibility of being logarithmic, we cannot start at year 0. Okay, so we're gonna do like what we did on the last, or the one before the last. We're gonna change this to 1. So if this is 1, well, 2001 is 1 from that, so that's 2, okay, 3, 4, 5, 6. Okay, so then go to your stat, edit. So stats, edit, and we need to delete the last part out. Clear that out. Okay, so we have 1, 2, 3, 4, 5, 6, and then we have 2.3, 2.6, 3.1, 3.4, 4, and 5.6. Okay, so then we go to stats. We go over to calc, and first let's check quadratic. So we're gonna go down to quadrag, hit enter, enter through. Now when you turned on your diagnostic, you notice now that it says it has R squared down there, okay? So let's see here. It has R squared, and on it says the closer the R is to -1 or 1, the better the fit, okay? So the R squared is 0.969, okay? So let's see, I'm gonna write over here, quadratic R squared is 0.969, okay? Because we're trying to see which one's gonna be the closest, okay? So then now let's go to quartic. So go back to stat, go over to calc, and this time we're gonna go to quartic. Okay, and our R squared, quartic, our R squared is 0.999. So that one's real close. Now we want to go to logarithmic. So go back to stat, go over to calc, and let's go down to number 9, logarithmic. I clicked on the wrong thing. There we go. And our R these are all, that one's the only one that actually says r. Okay, let's still look at r squared. Our r squared on logarithmic is 0.728. Okay, so if we're looking at all of those, which one is closest to -1 or 1? Well, the one that's the closest is going to be quartic. So that means that we want to use the quartic model here. Okay, so then after you decide which one is the best one, then you're going to write the best equation, then estimate the operation cost in 2008. So we want to go back and look at our quartic one because that one was the closest. So go back to calc and go to quartic. Okay, so that is going to be f of x equals 0.02 x to the fourth minus 0.27 x to the third plus 1.12 x squared minus 1.49 x plus 2.92. Okay, so then it's asking for 2008. So 2008 that's going to be x equals 9 because we are starting at year 1. So 9 years from this right here. So we just plug 9 in for all of the x's. And so whenever you type all of that in, you should end up getting around $14,620 is going to be about what that is. Okay, because it's f of 9 equals 14.62. Okay, and that's because we said in thousands of dollars. So it's going to be about that. Okay, all right, let's look at the next example. So the next one, it says the table below shows the balance of Marissa's savings account at the end of the year. Which model would fit this data best, linear, cubic, or exponential? Using the model, write a best fit equation, then estimate the year the balance will reach $1,500. So since it doesn't say logarithmic, we can start at year 0. Okay, 2010 is 1 from 0, 11 to 2012, 3, 4, 5. Okay, so then we're gonna go and we're gonna type all that in on our calculator. So we're gonna go to stats, edit. We have, well, if I can, 0, 1, 2, 3, 4, 5. Go over. We have 500, 540, 583.2, 629.86, 680.24, and 734.66. Okay, and then we're gonna go to stats, go over to calc. First, we're gonna check ln reg. Okay, we're looking at r squared. So for ln reg, r squared is 0.996. Okay, then we're gonna go check out cubic. Whoa, hold on. I accidentally clicked out of the screen. Okay. Cubic, r squared is 0.999. That's pretty dang close. And then exponential, r squared is also very, very close. 0.999 and keeps going on. Okay, but when you look at it, I believe the exponential is actually closer than the cubic. Okay, so since it's closer, it's going to be exponential. Okay, so then get the equation. So f of x equals 500 times 1.08 to the power of x. Okay, it says to estimate the year when the balance is $1,500. So our y is 1,500. So that means we have 1,500 equals 500 times 1.08 to the power of x. So we want to start off by dividing by 500. So we have 3 equals 1.08 to the power of x. We have to turn that into log format. So log base 1.08 of 3 equals x. Do the change of base formula. So it's log 3 divided by log 1.08, which should get you 14.27. And then 14.27 from 2009, that is going to be around year 2024. Okay, all right guys, so that is pretty much everything that we need to talk about for exponential and logarithmic regression.